so in this question, a ball of mass m is projected vertically into the air from the ground with initial velocity u. So it's going up. Oops. Here we go. It's going up with initial velocity u. And it reaches a height h. And then it falls back to the ground. While in the air, it has a resistive force of kv squared, where v is the velocity of the ball, k is a constant. The equation of motion when the ball falls can be written as this. Alright, so we're going to use that. Now, first of all, we're interested in the terminal velocity. Now we know for terminal velocity, that means the acceleration is equal to 0. So let's do that first, because that should be the easiest thing to do. So if we have a look at our v dot is mg minus kv squared. In this case, acceleration, of course, is v dot. So if we make that 0, we are left with mg minus kv squared. And this is not just any v, this is happening at terminal velocity v. Alright, so that's probably easy to forget, but don't forget to sub that in. So if we make that the subject, so I'll just put the k terminal velocity squared on this side, and then divide by k both sides, and then square root, so really bad working. We do get that answer. So terminal velocity, just remember, acceleration has to equal 0. Alright, now we've got that terminal velocity, and again, if you couldn't do part 1, we could definitely use that answer in our part 2 or 3, depending on when we need it. Okay, so if I have a look at part 2, we want to show that when the ball goes up this time. So as soon as it says when it goes up, I might write my equation of motion. So I'm going to always use a different equation of motion for up and a separate one for down. I'm going to split them up. So if we're coming this time going up, not down, so that's against gravity, so this is going to be a minus, and our resistance is always going to be, because it's resisting, it's always going to be minus as well. So here you can see we're going to have negative mg plus kv squared, and I might even divide by m. So I'm just going to have acceleration and just here. And what do I want for acceleration? Well, let's have a look. Show that when the ball goes up, the maximum height, so height is x, so I'm looking for x at the maximum, which is called h at the maximum. And if I look in here, it's got some velocity in it. It's got terminal velocity and it's got the initial velocity, u, so it's got some velocities in it. So I've got x and v, so I'm going to go with v to v dx here for acceleration. So let's go with v to v dx. Alright, now I probably want to divide through by that v, so I'm going to go like that. I hope that's okay. I'm just trying to save room here. Alright, and what I do want to do is tip it upside down, because I want h equals, or x equals, so I actually want dx to v. So tipping it upside down, I'm going to have minus, I'm going to have mv, mg plus kv squared, with respect to v, if I get rid of that, and I'll do it all at once, and I'll change this side as well, to, it's going to be my h when I finish doing the integral. So when I finish doing the integral, I remember I'm integrating with, I'm going up this time, so my velocity starts at u, and remember it'll finish here when it turns around at 0, so that will be u to 0. Alright, just saving a bit of room, so I hope that's okay. Alright, now if I look at that, it's I've got a log there, but in order to have a log, I've got the derivative at the bottom is 2kv. So I need to put a 2k in here, which means I need to divide by a 2k out here. So I'm going to have, and I'll put that m out the front as well. So I'm going to put the m on 2k out the front. That minus, I'm actually going to flip the limits. So now I've got a log of mg plus kv squared. It's all going to be positive anyway, so we don't really have to worry about that. Whoops. And I'm going from 0 to u. So I flipped that so I didn't have to use that minus there. So I'm going to get m on 2k. When I sub that in, I'm going to get mg plus ku squared, and when I put the 0 in, I'm going to get the m log of mg, and that's going to be at the bottom if I use log logs because it's a minus. So I'm going to get log mg plus kv squared, ku squared, sorry, that's better, on mg. Alright, there we go. So now that's my h, but have a look at what it's doing here. It's saying show that the maximum height here, and look at that equation there. It's got terminal velocity in it. Mine doesn't have terminal velocity in it, and mine has, first of all, it's got some k's in it. This one does not have some k's in it. So perhaps we can use this, remember this is terminal velocity, to put terminal velocity in and get k out. So if I rearrange that equation for terminal velocity, I've got Vt squared is mg on k, and k, because I can see I've still got some m's and g's in there, I just need some Vt's and not k's, so why don't I just swap out the k? So if I make k the subject, I've got mg on terminal velocity squared. So if I sub that into this equation, I'll do it in purple so you can see. So I'm going to get h is equal to m on 2 lots of k, and this is my k here. So I'm going to get 2mg, 2 lots of that on, I'll just put it on, I'll do it here, Vt squared. And log, I probably should just done the working on the side really. So here I'm going to get log mg plus, again it's ku squared, so mgu squared on Vt squared all over mg is what I'm going to get. Now you can see here that these m's will cancel, and that Vt squared on the bottom of the denominator of the denominator, the fraction on the denominator really is at the top here. So I'm going to get Vt, I don't know why I'm putting brackets, just because it looks funny otherwise. And I've still got the 2g on the bottom, and for the log, all those m's are going to cancel if I divide both top and bottom by m. And you can see I'm going to get g on g, so that's 1, plus gu squared on Vt squared, but it's on g, so those g's will cancel. So I'm just going to get u squared on Vt squared, which is, except it's written nicer there, which is what we've asked to show. So sometimes, you know, we can look at the hints, the show that hints. Alright, and the last one, when the ball falls from height h, it hits the ground with velocity w. Alright, so we need to show this here. Now, if you think about what we've found already, we can definitely use that. So again, this is when the ball hits the ground, so this is on its way down. So we've got all the things up there because we had to show that. So I don't know if I need that again, but I'll just leave that there in case. Alright, so because we had to show that, I can use those things there. So the ball is going down and it hits the ground. It falls from the top height, so velocity is 0 at the top, and it's falling, so it's 0 at the top, and it's falling down, and of course it's height h, and it hits the ground with a velocity of w. Alright, so clearly we're going from velocity 0 to w, and it's going down, so I'm going back to this downward motion equation that we had here. Now, if I use, well, you know, if I look at the question, it's all to do with the height, so that's the x, the displacement, and the velocity. So again, v to v dx for my v to v dx for my acceleration. I've already divided by m here. And the other thing to think about would be, if I look here, I need these velocities, terminal velocity, which is not one of these, 0 and w. I need the u and the vt, which I'm not going to get from these velocities. But I will get, I guess, from height up here. And the other thing is, I do know my k, because I've got a k in there. I know my k is equal to mg on vt squared. So I'm going to put that in now. So I've got v to v dx. I'm going to go to straight away. No, I won't. Okay. So I'm going to have g and alright, I'll do it properly because I'm going to confuse myself. So m v to v dx, so that's our acceleration, is equal to mg minus, and here I'm going to end up with, because k is mg on vt squared, I'm going to end up with that. Now it's going to get confusing, but at least I can divide through by my m's. Alright, so I'm going to get dv dx. Now I would have made this a common denominator. So it's g vt squared minus g v squared, and I'm dividing through by this v here, so this will be times v there. So alright, so if I do tip it upside down as well, because I know I'm going to have limits that are these velocities here, so dx to v, so I've got the vt squared, and I've got v, I'm just separating them because the vt squared is a constant. We already know the answer to that. And then look at this top, I can factorize it by g, and g is a constant, and I've got vt squared minus v squared left there. So then if I do integrate, I'm going to be left with x, which I'm going to call my h on this side, and I'm integrating here, and I've got a constant which is vt squared on g, and I'm integrating between 0 and w for my velocities, and I've got v on vt squared, which is a constant, minus v squared dv. Alright, so what I can do is have a look at that and go, remember you're integrating with respect to v, so I need a negative 2v on top to balance, so negative 2v, which means I need a negative 2 under here to make that work, and then I've got a log, which is nice. So I can keep or not keep that negative and change the limits if I want, or just whatever you like to do. So here now I've got log of the bottom, and it's between 0 and w, but I've turned them upside down. So you can see you're going to get vt squared on 2g, and when you put 0 in, you'll get log of vt squared, and then you'll get minus log of vt squared minus w squared there. Alright, now we haven't quite gotten what we want, but remember this is equal to h, and we do know what h is equal to. Unfortunately we can't see it though. Alright, so here we've got h is equal, h from number 2, from the second part, h is equal to vt squared on 2g log 1 plus u squared plus blah, blah, blah. Alright, and if you look at what we're trying to find, you can see there's none of the other stuff in there. There's just w squared, u squared, and vt squared. So I'm going to use that h value from, I need to get down here. Alright, what was h? It was vt squared on 2g log 1 plus u squared on vt squared. hopefully. Now you'll see that they both have this bit here, so we can divide through by that. And then we've just got the logs left, so we can exponentialize both sides. So what have we really got is 1 plus u squared on vt squared, which equals vt squared on vt squared minus w squared. So that's looking more like what we're trying to show, hopefully. And even actually I might make that vt squared on vt squared, so that we can just multiply across. So if I kind of, what we're not supposed to say, cross multiply, I'm going to end up with, and I'll just move it this way a little bit and up. Here we go. So I'm going to get vt squared plus u squared times vt squared minus w squared equals a vt to the power of 4. Okay, so if I have a look at expanding that out, I'm going to get vt to the power of 4, that's that one. I'm also going to get negative w squared vt squared, that's that one. I'm also going to get u squared vt squared and minus u squared w squared. Okay, so are we close? So if we have a look at what, so these two anyway, if we minus these, they will cancel, so that's great. And if I had a look, remember we wanted, all I can remember is we want 1 on w squared. Alright, so I'm going to put my w's together. There's two terms, this one and this one, that have w's in them, and I'm going to factorize by w squared. When I do that, is that what I'm going to do? Let me just put them all the w's on one side. So I'm going to have w squared. Yeah, so basically, I'm going to put them on this side so they're all positive. W squared, u squared, and w squared vt squared. And on this side, what's left is u squared vt squared. I think that is what's left. So if I want, w squared by itself, I'm going to have to go up here. I've got w squared and u squared plus vt squared. You're probably much quicker than me at this bit. Alright, so I'm going to divide by, because I want u squared, w squared by itself. Actually I want 1 over, I can do that so I don't make a mistake. I'll do this first. Alright, so if I tip it upside down to get 1 on w squared, I get u squared plus vt squared on, and I'll just put them on like this, on u squared vt squared, on u squared vt squared. So I'll get 1 on vt squared and 1 on u squared. I'll leave it to you. But that, I think, is what we wanted to prove. Let's check. There we go. 1 on w squared is 1 on u squared plus 1 on vt squared. Hope that helped.